Hi everybody. Welcome to Dome at Home for Thursday, June the 27th, 2024. Don't get ahead of myself here. I'm your host, Scott Young from the Manitoba Planetarium, planetarium astronomer at the Manitoba Museum. And we have all sorts of great stuff for you in the show today. My lighting looks a little strange here, so I'm not quite sure why that is. Is that side? No, that's that side. Didn't look like that just moments ago. Well, when we get to some of our pictures, I'll see if I can correct that. Anyway, thanks for everyone for saying hello in the chat. It's always great to see who's there with us and where you're coming from. If you're new, definitely tell us where you're watching from. We have people all across Manitoba and all across North America, so it's very good to see folks. All right, let's see. Hi Ulrika, nice to see you. Craig, yeah, we'll talk a little bit about Mars later in the show. All right. If you have any questions, drop them in the chat and I will try and get to them as we go. Today we're getting into summer mode. Yesterday was the last day of school programs at the Manitoba Museum. We survived. It was a very busy year. Lots of field trips all coming at the end of the year. Of course, that's sort of a standard for us. This year it seemed even busier. I'm not sure if that was, if the numbers will bear that out. Maybe I'm just getting older, but it was great to see so many people coming through the museum, science gallery, and planetarium. That ended yesterday, although I think we're still open for, classes or groups that just come in, but the guided programs where there's a staff person doing a program for you has ended. We have 2 whole days, well, today and tomorrow, to change things around for our summer programs, which all open on Saturday. So it's a busy time of the year. And of course, for anyone that has kids, this is a busy time of the year as well. My grade 8 is graduating tonight. She's at her grad dinner right now. And so all sorts of fun things going on there. Okay. We have, lots of stuff coming in here. We have a lot of things to get through today in terms of content. I'm finding that the cool space stuff segment of the show is becoming bigger as time goes on. There seems to be so much happening in terms of space exploration that I've had to pick and choose a little bit, and I don't think I will get to absolutely everything that happened in the last month, but we'll try and hit the high points. We're also going to take a look at the things we can see in, in the sky this summer, looking at some of the events, and we're finally going to get back to being able to see some planets, but you'll have to get up early. Now we're just past solstice, I guess a week past solstice. It doesn't really get dark. If you're here in Manitoba, excuse me, if you're here in Manitoba, the sun only goes a little bit below the horizon after it sets. It sets very late, 10:30, something like that. And then it just dips below the northern horizon. It doesn't go far enough below the horizon that the sky gets truly dark. We have another 2 weeks or so of what we call perpetual twilight. So it never really gets dark. We had some staff in the planetarium. They were saying, hey, something's wrong with the stars because they just aren't being as visible as possible. And we were looking at technical issues and we thought maybe the projectors were going and things like that. We finally realized, no, it's just because it's solstice and the sky never gets dark. So in some ways, this is the worst time to look at the constellations or the stars particularly. In other ways, it's the best time because it's so nice out and it doesn't feel like a problem to stay up a little bit extra late, especially once you're on summer vacation. So we're going to look at a little bit of that stuff. I also have, I got some great images and questions from our good friends Ruby and Andy, and we'll take a look at the images and answer the questions that came in with them. So actually, maybe we'll start there. Why don't we start with some of your images? You can always send us any pictures you take, or if you have any questions between shows, you can always send it in to us. This is a great shot of the full moon on just a week ago, the solstice by Andy. This is a shot through the telephoto lens as it's just coming up above the trees. Beautiful sort of yellowy orange color as the moon is rising. We're looking through the denser layers of the atmosphere and there's more water vapor we're looking through and so on. That scatters away a lot of the bluish colored light from the rainbow, and so you're left with this sort of yellowy orange thing. People think that's the harvest moon. It's just that's when people notice it, because that happens at a time when lots of people see it. But as you can see here, beautiful capture by Andy. And if we go on to our next image, here's the wider image where it's just coming up. Obviously, you've got the same situation as I do, where you have to move to the right spot of your backyard to be able to see through the trees and so on. But great shots here. And Andy was asking, is there always, like, is the fact that there's the solstice and the full moon on the same date, is that significant? Is that something that always happens? What's going on here? And it turns out that it's basically a coincidence. The solstice and its partner, the equinox, there's two of each in the year, have to do with our orbit around the sun. And basically the Earth goes around the sun, and at four different points, the four quarters of the orbit, if you want to think of it that way, are the extreme points of the way the Earth is tilted. You know, the Earth is not straight up and down compared to the orbit. It's tilted a little bit, and so as it goes around, sometimes we're tilted as much towards the sun as we can. Sometimes we're tilted as much away from the sun as we can. And then there's the equinoxes, where we're sort of tilted at a right angle, so it doesn't really affect us. That's to do with the seasons. That's what gives us our seasons, and that's what the solstice is. On top of that, we have a second cycle going on, because as the Earth goes around the sun, the moon goes around the Earth. I'm going to run out of fingers here to make my model, but that is a completely separate phenomenon. And so things like full moon, while it has to do with where the sun is, it happens on its own cycle. And so full moons can happen on pretty much any day. The odds are actually not bad, though, of there being a full moon on a solstice. If you think about it, you've got, you know, the moon takes a month or so to go around the Earth. And so we've got 12 months in a year, and there's four different points. You've got two solstices and two equinoxes. So the odds are 1 in 7 in any given year that there'll be a full moon on one of those 4 dates. So it happens more often than you might think, but it is completely random. Not random. It's periodic and can be predicted, but it's just a coincidence that they both happened on the same time. This was also a very early solstice, because we had a leap year, and so that pushes the calendar artificially forward a little bit, and that means that everything gets a little bit out of sync until it gets back into sync. Calendars are complicated. It would be so much easier if we didn't try to tie it to the way our planet moves around the sun, and the way it spins on its orbit, and the way the moon moves, all these different astronomical phenomenon. If we just had a metric decimal calendar or something like that, it would be much easier to understand once we all got used to the fact that the sun doesn't rise at the same time every day. Anyway, it opens up a whole can of worms in terms of those kinds of changes. We can't even get rid of daylight savings time, let alone change our entire calendar system. So I don't have a whole lot of hope that that's going to be happening. Great shots though, Andy, and thanks for the question as well. And some of you may have seen this around Manitoba as well. We had a couple of really active thunderstorms in the last little while, and then afterwards we had a beautiful rainbow. Not just a rainbow, but a double rainbow. And so this is another shot that Andy managed to pick up. He gets some quite good shots here, and you got the bright rainbow across the sky that people are sort of familiar with, and then you've got this faint secondary rainbow here. And this is actually a really great shot to illustrate some really interesting things. First of all, look at the brightness of the sky inside the rainbow compared to outside the rainbow. That's part of the phenomenon of what's causing this. The sky inside a rainbow is brighter. The sky outside that rainbow is fainter, at least for what we call the primary rainbow, the bright one here. This one here, and I'm not sure how well it looks out there once it goes through all the processing in internet land, but here in the primary one, we have sort of red at the top, orange, yellow, green, blue, violet, so on. This one's backwards. It starts with red at the bottom and goes up through, you can just sort of see the green and blue edge on this top part here. It's reversed from this one, mirror reversed. All of this provides clues as to how this kind of phenomenon forms. First of all, as the name suggests, you need rain, or at least water droplets in the air. It doesn't have to be actively raining, but when light goes from the air into something that is transparent, something like, say, a water droplet, it gets split up into the rainbow of colors. This is, I think we do this in grade 4 here in Manitoba. Most of us sort of have learned the prism and the Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. Oh, of course, there we go, in case you need to see that. Interesting fact, indigo is completely made up. Indigo was a color that Isaac Newton made up because not only was Isaac Newton a physicist, he was also an alchemist and a bit of a sorcerer, or thought himself one. And 7 is a magical number, so there should be 7 colors making up light. And so that's where indigo comes from. Interesting guy, Isaac Newton. I like his gravity stuff, maybe not into all the other stuff that he was on about. But anyway, boy, I get distracted. This is what happens when light goes into another medium like water. Now, water droplets are not shaped like a glass prism like this. They're shaped like a circle. And what you have is the sunlight comes in from the top left there. It goes inside the water droplet and splits into the colors. And then when it hits the inside of the water droplet, some of that light might actually go out of the water droplet and keep going on its way. But some of it is reflected internally. And then that reflection goes to the other edge of the water droplet, and then is refracted again, spread out even more, and it goes shooting off into this. Now, it doesn't matter how big the water droplet is, whether they're big ones or small ones or whatever. All that matters is the water droplet itself is made of water, because the what's called the index of refraction, the spreading of the light, only depends on what the material is. So if you're going from air into water, these angles will always be exactly the same. And so rainbows are always exactly the same size. And you can check that if you're very careful about how you take your photographs. Anytime you image one, it will be always exactly the same size. What's interesting, though, is that here, if there's enough light, some of this light might come out here and make the bright one, but a little bit might get internally reflected again, and it will go shooting up to the other side here, and then also go out at a slightly different location. And so if conditions are right, there's enough water droplets so that there's enough of this double refraction going on, you can wind up with the picture that we had here of the second rainbow. Theoretically, that can happen an infinite number of times. So technically, there are always an infinite number of rainbows that happen during whenever you can see a rainbow. It's just that each one gets successively fainter and fainter because there's less light to it. And each one will be mirror reversed from the next one. So if we could see the third one, it would be out at this same spacing, and it would be reversed from this one. So it would be the same as the first one, with purple on the bottom going up to red on the other thing. So again, atmospheric phenomenon can also get very, very complicated. We think rainbows, but it tells us some inherent important stuff about light and about, just the stuff that's in our atmosphere. This is the same technique that we use to figure out what's in stars and what's in a planet's atmosphere that we observe with the James Webb Space Telescope or things like that. And so this same technology, at obviously higher resolution to a rainbow picture, is how we do astronomy. Okay, great shots. I really love this. I got a couple pictures myself. I was going to put them in, but then Andy, you sent in yours, and it looks so much nicer. So we're just going to do that one. While we're on the topic of prisms, the Pink Floyd show at the planetarium is still on. It's actually playing right now, and it's playing again on Saturday, and then it's going to be off for the summer. We won't be running it again. We might run it again in the fall, but I think there's still some tickets available for Saturday's show if you're into that or you want to see it again. It's a great show. I've seen it about eight or 10 times already. Okay, let's see. I've got some questions that have come in here. Okay. Oh, lots of people checking in. Jacqueline from Northwestern Ontario. Nice to see you. Hi, Tiffany. Hi, Val. Hi, Ben. Hi, Chris from Houston. Why is the sky color different? Yes. Um, so when we look at all of this, not all of the light gets refracted and reflected there. Some of the light that would come in here actually gets just reflected off the outside of the rainbow and goes shooting back almost straight. And if you figured out sunlight all coming in the same direction and doing all of that, any light that hits out here outside the rainbow would just get reflected off at that angle, because when the light comes in, of course, it reflects off at the same angle that it hits at. So if it hits out farther here, it goes farther out. But if it comes right in and hits the center of the thing, it comes right back out. So basically, most of the reflected light winds up filling the inside of the rainbow, and that's why it's brighter. And this part here, any of the light that is reflected is basically not reflected back towards us, and so it doesn't show up and we don't see it. We just see the regular. This is actually the actual sky color, and the inside of the rainbow is brighter than it would be because of that reflection effect. Good question, Val. Oh, and Tara says, go see the Pink Floyd show. It was amazing. Yes, yes, indeed. Chris is asking, by the way, are we planning to telecast the NOVA event whenever it happens? We talked last week about the, and actually, if you've been on the internet at all, you've seen hundreds of posts about T Corona Borealis, the blaze star that is expected any day now to get bright. Yes, we will absolutely go live as soon as it happens, if it happens when it's dark and clear here. You can actually go to spaceweather.com, which is the place that usually forecasts auroras and stuff like that. They have text alerts available, and if you sign up with them, they'll actually text you when it goes off, because they're plugged into the sort of astronomical reporting stuff. I'm getting daily or sometimes hourly reports from the Variable Star organization that I'm a part of. Just everybody is observing the star, waiting for it to explode, and I've just been seeing it all at the same brightness, and then someone puts in an estimate that is higher, and so right away we all check our emails, and then it turns out that no, that was just a person that either made a mistake or was a little bit off, or it wasn't the increase, it was just a little blip. Kind of exciting, waiting for this thing to happen. We'll do a special event when that comes up. If you watched last month's show, which is available on our YouTube channel, and I think still on Facebook, you can watch the segment all about that, where we talked about how to sort of find the star and what to look for and how bright it gets and so on. All right. Hey, Paul from the east side. Oh, and Kevin as well from out east. A couple of my friends from the Royal Astronomical Society of Canada watching in, and both of them are experienced observers as well. And like me, we've all grown up, since we were kids, knowing about this star, because the last time it happened was in 1946, which is before all of our times. And so you read about it and you think, oh, I'll be alive when that happens. I'll wait for that. And now it's here. So pretty exciting. It better go off on schedule. If it doesn't happen, I'm gonna want my money back. Oh, Brian, hi, nice to see you. Brian is asking about the decommissioned Russian satellite. Yeah, so today there was a pretty interesting situation where Mission Control suddenly called the International Space Station and said, hi, everybody, I know you're asleep, but please get up and get into the emergency escapes hatches and just wait for further instructions. And so they literally all went to the various spacecraft and got ready to eject and escape from the space station. A Russian satellite that is decommissioned and is just sort of floating around up there, like many pieces of junk that are up in space, suddenly fragmented. We don't know if something hit it. We don't know if one of its fuel tanks still had something inside and maybe exploded, although it's been up there sort of inert since 2021. So it's probably not a fuel or it's probably not something the spacecraft did. I suspect something probably hit it, a piece of space junk that was too small for us to be tracking. And it's fragmented into hundreds of pieces. And it was close enough to the space station that until they could figure out what direction those pieces were going, they just invoked the emergency procedures. So all the astronauts basically were woken up with, the big red alert alarm kind of thing, I'm sure, and all went to their various spacecraft. They were only in there for about an hour, though, and by then NASA had tracked the positions of the particles and where they were moving and the sizes, I assume, and decided that there was no threat to the space station, which is good. But this is the kind of thing that just makes it worse in space. You wind up with, so many pieces up there, and then when they start to hit each other, they make more and more pieces, and eventually you reach a point where there's just so many pieces flying around up there that it's not safe to put people there anymore. That's sort of the way of humanity. We find a new technology and we can just barely do it, so we use it just without thinking too much about the future, because it's new and it's exciting, and we can just barely do it. And now when we realize, oh, if we had just done things a little differently, things would be in a better situation. Let's see. Zeus asks, is this the debate live stream? Yeah, no, we're not covering that particular space story today, unfortunately. But I do thank all of you who decided to tune into to our show instead of that other show in the States right now. Okay, let's move on from our rainbows here. We have a brand new show opening at the planetarium. Normally, I don't like to spend a whole lot of time on all of these because many of you are museum members or visitors, and you can go to our website. But I did want to show you just the preview for this show because it's a really good one. It's a program called Forward to the Moon, because NASA doesn't like saying we're going to go back to the moon, because going back is not what NASA's about. And it is really a good look at where we are in terms of lunar exploration. It opens on Saturday at the planetarium here, and I'm sure it's opening in planetariums around the world, actually. It's just been released by the Fisk Planetarium in, I think they're in Boulder. But they do some good stuff. I'm just going to show you the trailer here, and then we'll talk a little bit more about it.
Within a single lifetime, we've progressed from the first space rocket launch to using space technologies in our everyday lives. Both governments and private companies have taken up the challenge, launching near-Earth satellites for communication, imaging, and navigation. Low Earth orbit has become another part of the world economy. The International Space Station has been continually inhabited for over 20 years, hosting teams of astronauts who carry out research and trial new robotic technologies. Now, we are ready to start a new chapter in the history of human endeavor, to take our first steps towards a permanent off-world presence. Forward to the moon.
So Forward to the Moon opens on Saturday. If you thought that voice sounded familiar, Carrie Byron, formerly of Mythbusters and now of Crash Test World, narrates the show. And I have to say, she is one of the best narrators I've ever seen for a planetarium show. She has an enthusiasm that carries, and I'm putting her up there with, the likes of Patrick Stewart. Sir Patrick Stewart has narrated many planetarium shows in the past, and he's always sort of been the gold standard for that deep gravitas kind of narration. But this kind of topic really works with a young, enthusiastic voice that is not afraid to get all excited and make some squee noises and things like that, because going to the moon is a pretty amazing adventure. So what we have now is a program that begins with a very quick look at the history of lunar exploration, just to set some context, and then the updates on where things are with the Artemis program, which is the chance to return to the moon. Artemis 1 flew earlier this year, as no humans aboard test flight. Artemis 2 with 4 astronauts, including Canadian astronaut Jeremy Hansen, will be launching, we hope, mid next year. And then Artemis 3 is scheduled to land on the moon sometime at the end of 2025. And so is Artemis 4 about a year after that. During that time, we'll also be building the Gateway Space Station with Canadarm3 and all sorts of things. It's a really great show, and I highly recommend you tell your friends about it and come and see it, because it's I think one of the better shows that we've had in quite a long time. And I just really love Carrie Byron's enthusiasm. So dream to write a show myself and get her to narrate it. That would be pretty cool. All right, let us move on now. It's time to take a look at a few of the things that are up in the sky. I had to set my planetarium system here for 11 o'clock for the stars to really come out, because it really doesn't get very dark until quite late. And of course, we're on daylight savings time. So actually, the time that it gets sort of darkest here in Manitoba is about 1:30 in the morning, roughly, once you account for daylight savings time and the fact that we're not right in the middle of our time zone. That's sort of local midnight, is about 1:30 in the morning. So that's pretty late. In the east, we have all of the summer constellations that we've been seeing for a little while. The Summer Triangle, oh, where's my mouse? There we go. Summer Triangle, making up the 3 bright stars here. And then we have some of the other summer constellations. Hercules up at the top here. Down here is Ophiuchus. And right skimming the bottom, we talked about these last month, Sagittarius and Scorpio. And right in about here is the center of the Milky Way. The Milky Way is hard to see until it gets a little darker, though, so we're actually just going to make things darker. Kevin's asking a little bit about our latitude. Yeah, we're at almost 50 degrees here, Kev. So it's about 49.9 degrees latitude. Our friends in Edmonton are, I think they're at almost 50, almost 53, and so they have it even worse than we do. So there we go. By about midnight local time, you can start to see most of the stars and the Milky Way. And we talked about the Milky Way a little bit last time, scanning it with binoculars. This whole area in the south part of the Milky Way is just full of little star clusters and so on. And if you stretch up through the Summer Triangle, again, there's all sorts of wonderful little sights, and the dark clouds of the dust and so on in our Milky Way galaxy. If we look way over to the east, by the time it gets dark, we're already starting to see some of the fall constellations. The Andromeda galaxy is right in about here in the constellation of Andromeda. I always think of that as a fall constellation because that's when it's visible early. But yeah, you can start to see it now. And the Andromeda galaxy, about twice as big as our galaxy, is the farthest thing you can see with the unaided eye. If you get to a dark spot, you can see this little fuzzy patch here, and it is about 2.5 million light years away. So pretty impressive. And actually, if we wait till it's at our darkest, we start to see a few other things happening. If you wait till about 1 or 2 in the morning, you start to see the objects of our solar system come up. There are no evening planets of any note. There is nothing that you can really see for the solar system until you're able to stay up way past midnight here. We'll set things for about 4 in the morning. That's when we sort of get our best view. I'm not sure how many of these views I'm going to see myself. I'm not a morning person. Look, the planets, they're all in a parade in a line, just like they are every night. That whole planet parade that we talked about last month, it's still going on. It hasn't changed. Jupiter is just rising over here, nice and brilliant. Saturn has sort of been the highlight. It does get high enough before dawn that you can start to see some details. The rings of Saturn are almost edge on to us, though, and so they're not quite as easy to see. They're still there if you have a telescope, for sure. And it's an interesting time because if you do have a telescope, one of the big moons of Saturn, Titan, is actually crossing in front of the disk of the planet. Normally that doesn't happen because Saturn's usually tilted to our line of sight, and so the moons sort of go down below it and then up above it and so on. But there's one coming up on the morning of June the 30th. And that'll be interesting to see. It's a pretty advanced thing. I don't know if I'll be able to capture it with my telescope and camera, but certainly I don't need many excuses to look at Saturn. Over here we have, actually the planet Neptune is right about where the moon is as well right now. It's much too faint to see. Mars is starting to come up, Uranus over here, and then Jupiter. And if we sort of fast forward through the month, the moon will click through fairly quickly. Day by day, it's in a different position, passing a different planet or so. This is July 1st, Canada Day. And so it's kind of over close to Mars. And then making a nice triangle July 2nd with Mars and Jupiter. And right by the Pleiades, that little star cluster is in there. Here, we'll just zoom in a little closer here. And now this will be very low in the sky, but if you have nice clear skies, it'll be a beautiful view, I think. A thin crescent moon like that, right next to the Pleiades and a couple of bright planets. And then as the time goes on, Jupiter doesn't really move that much relative to the stars this month, but Mars is moving quite a bit towards the left. It's in what's called retrograde, and it's moving off towards the Seven Sisters there. So, and Uranus is kind of in that direction as well. So all of the planet activity is really happening here. We've gone to the almost to the end of July here. Here we go, is the end of July. On the 30th, we'll have another nice grouping of Mars and Jupiter and the crescent moon and these two beautiful star clusters, the Pleiades and the Hyades, with Aldebaran, a nice orange star that's perhaps almost as bright and almost as orange as Mars. So that's a time to set your alarm for. If you're not going to get up every morning, July 30th is probably a good morning to do it if you want to catch some of these views. That's still 4 in the morning though. So if you want to see planets, that's pretty much when you got to get up. Saturn rises quite a bit earlier. I mean, you can see Saturn, I think, just after midnight by the end of the month. Yeah, here we are. It rises about 11 o'clock, it looks like, at the end of July. So, 11, 12 o'clock this month. But you don't get a good view of it until it's up above all this horizon haze. You really need a planet to be, a third of the way up the sky to the zenith before it's clear enough to get a good view with telescopes. So there we go. Okay, what else do we have here? We got some questions. The moon is not rusting or turning red. So the moon is just the same color that it always is. This show, that was, thanks, Hollis. Our show is way better than the debate. I don't know about that. I think it would be funny to watch, but anyway. Oh, Linda, nice to see you from Vancouver. Yeah, cloudy out there, hey? Just one of those things that is inevitable for the West Coast, I guess. That's just the way it goes. Okay, I think what we're going to do here is we're going to switch over for some
Cool space stuff.
Oops, have just a little glitch there. There we go. This is something Craig mentioned right off the top. Mars has frost on it. Now, this came out a couple of weeks ago. A European Space Agency spacecraft took this image. This is Olympus Mons, the largest volcano in the solar system. It's 20-some thousand feet high. I forget the number, but the thing that I do remember is someone figured out if you were to heliski from the top of this down to the bottom, accounting for the lower gravity, you could ski one way down and it would be like 60 minutes of skiing. So that's a pretty big mountain. And in the caldera, in the crater there's this white material, which is water ice frost. Now, we know that there's water ice on Mars. It's in the polar caps. It's in the soil, buried underneath all those kinds of things. But it is definitely not usually seen near the equator. And that's where this is. So this basically tells us that there's more water on Mars than we sort of thought. And if we extrapolate this out, that means that there's more water. Now, the reason we're excited about water is two reasons. One, water indicates places where you might look for life. And then also, water indicates, a good place to land your Martian spacecraft, because then you can use the water that's already there rather than bringing it with you. Now, I don't think the water at the top of a 20-some thousand foot volcano is going to be terribly accessible or useful for astronauts, but it certainly is interesting that it's being found in all these locations. Now, obviously, just like on Earth, mountains get colder as they go up to the top, so it kind of makes sense that up at the top there would be where we find frost. But I'm kind of surprised that we haven't seen this before, because there is, I see some questions going on there. I'll get to those questions in just a second. I see that the frost here is pretty visible, and I'm surprised. Like, we've had orbiters around Mars for a long time, and I don't think that we've had this kind of discovery before. So it's pretty interesting. Maybe something is changing. Maybe it's just the time of the year. Mars has seasons just like the Earth, so there's all that kind of stuff. Okay, let me see here. I got to go back and catch the beginning of some of these questions here. Okay. So I'm not sure what you mean, Zeus, about the moon rusting. I haven't heard anything about that. And the moon is not, I mean, maybe you're thinking Mars. Mars, the red color largely comes from iron oxide, which is rust. And so the rocks have a lot of iron in them. There used to be a lot of water there, and so there's been some rusting and things like that. So that's certainly something that might be the source of that. The moon doesn't really have the same kinds of situations. There's really never been any kind of water on the moon. There might be there are little bits of water ice, but not in the amount that would take to really cause the same situation that we see on Mars. If you can find the link, send it to me. Our contacts are either on Facebook or YouTube there, or by email, space@manitobamuseum.ca, and I will look into it and I can get back to you. That's the somewhat interesting and somewhat fascinating and somewhat frustrating part of where we are in science right now. Stuff literally happens so quickly that we just can't keep up with all of it. I mean, I've had indication or things going on where I'll go in and I'll do a planetarium show and I'll say something, and that afternoon I'll check my email and there's a press release changing what I just said because there's been a new discovery. You know, like the number of moons of Jupiter. I got caught on that one day. Suddenly there were 40 more moons of Jupiter than I had said there were that morning. So yeah, send me the link and I'll be happy to look into it and check it out. Okay, let me see here. The last month we had the big Starship test flight. We talked about Starship number 3 last month, and they launched another one right at the beginning of June, and it went mostly well. I have to say. I mean, I was a big non-fan of their first launch because they basically blew up their concrete launch pad and sent concrete flying for kilometers and did all sorts of. It was a really reckless kind of launch, and yet the number 2 was better. Number 3 was pretty good, except both spacecraft blew up. And number 4, they actually had mostly a successful test flight. So this big rocket with Starship at the top and then the rocket at the bottom took off, and then the two separated up in space, and the booster flips around and comes back to land because they want to make it reusable. Now, they're not allowed to land it back in a populated area yet because it's still, questionable whether it will work. So they went out to the ocean and they landed on the surface of the ocean, and then it just sank. They weren't going to recover it. They knew that, but they were going to try and land just to test out all the stuff. They had a floating buoy out there with a camera that was able to see the thing. Actually, it looked like it was coming in sideways. You can see that there's some kind of fire there. One of the engines blew up, but it corrected itself and it landed on the water and then slowly toppled over and sank. So other than whatever's happening with this engine here, that was a pretty successful operation for something so big. Like, this thing is a massive rocket. Returning it to Earth is very, very difficult. And to get that good at it with only 3 practice launches beforehand. And Ben says, yeah, the next one may try landing back at the launch pad. They have these 2 things at the top called chopsticks that are supposed to basically, the thing will land and it'll grab onto them. I still don't know how I feel about that whole plan. It's very, very sketchy. But I'm saying that because it's never been done before. So I will take a look at what they do. The Starship went on into space. They had pulled out a lot of the experiments that they were going to do and tests, and basically this was a test of the heat shield. And so the Starship went up there, and then it came back down, and it re-entered, and it again provided some amazing footage, live footage, because they've got Starlink. They can, Zeus, yeah, I see you're trying to post links. They don't allow link posting on these chats, unfortunately. So you'll have to send me an email, or you can send me something through the Manitoba Museum's Facebook page, and I'll get that. Yeah, the heat shield had some problems, as you can see. The fins that are on the side, they swivel, and that means there's a joint between the moving part and the body, and the heat got in there, and it started melting the fin from the inside, and pieces were falling off, and we were just watching this thing coming down, wondering if it would hold together long enough to actually do the same thing, where it would come and it would try and land and so on. And it did. They didn't have a camera out there, although I've seen a bunch of AI-generated photos of, oh, look, this is me in my little rubber boat of the Starship landing. Those are fake. But obviously they have some work to do on the heat shield, because if this was a human spacecraft, the fact that it made it back to the ground would not be very much consolation for, the fins melting off in flight. So we'll have to see how that works. Obviously they're working on it, and we don't know when the next flight will be, but they're going very, very quickly, which is kind of, I'm not a huge fan of certain individuals associated, but the company SpaceX and the engineers and the scientists and the folks that are working there are doing actually a pretty good job of trying to respond to the problems and trying to rein in the enthusiasm of the CEO. And I have more faith in the Starship program certainly than I did last year. I still don't know that they're going to be ready to land on the moon in 14 months. They still haven't been able to put people on it at all yet, so we'll have to see. But yeah, anyway, Starship was certainly exciting. The other Starship that was up there is Starliner, the Boeing Starliner spacecraft. Went on its maiden voyage with astronauts. 2 astronauts took it up to the space station. The launch was delayed a bunch of times with a bunch of problems. They got into space. They had some issues with helium leaks and with thrusters shutting down. They docked with the space station, and then the NASA has repeatedly delayed their departure from the space station until they are sure that those thrusters, which are needed for re-entry, will be reliable. Because essentially, once they leave the space station, if those thrusters don't work, they can't come back to the space station because it would put all those people at risk. And if they can't re-enter on their own, or if the thrusters work improperly and put them into like a steep path where they burn up, there's all sorts of possibilities that they just want to eliminate. The other problem is that all of these thruster problems are in this part of the spacecraft, the service module, the back end, and that gets dropped off and it burns up in the atmosphere. It doesn't come back. So they can't check it after the fact and do sort of a post-mortem and say, oh, well, this is what happened. Any problems in the Starliner ship itself, this gray conical part where the astronauts sit, they can see what happened and fix that. But the service module, they just can't. So they decided to stay up there, and it revealed one of the problems, I think, with Starliner. Starliner is designed to land on the ground in the United States. And because of the way the orbit of the space station goes, they only have a landing attempt every 4 days. So it's not like they can just come back anytime, or, well, they can. In an emergency, they could come back and land in the water, and then they get picked up by a ship or something. But they prefer to land back in the United States, and that opportunity only happens every 4 days. So that is a little bit of I think, a limiting factor on the usefulness of the way this spacecraft is going. It's just been, I don't want to say cursed, but they've certainly had their share of problems with it, and they're not comparing very favorably to the SpaceX Dragon, which is the other spacecraft that is being used to take astronauts to the space station. There's a press conference at 1 o'clock Central Time tomorrow where NASA and Boeing will be discussing the departure of this spacecraft. That sounds, well, not ominous, but it sounds like they will hopefully tell us a date, or they will tell us that they are not going to undock with the spacecraft, that they can't trust the thrusters, in which case they would just wait for the next mission, the next crew mission to come up, and the people would come home in that. They would save some extra seats, essentially. That would be crushing for Boeing. Well, and for NASA, because you don't just want one, when NASA builds their own spaceships, NASA can decide, okay, well, we have to have a spaceship, we'll cut something else if budgets get tight. But if a private company decides that, oh, we're going to go do something else now and we're not making Dragon spacecraft anymore, what are you going to do about it? Or if the price suddenly goes up by 10 times because, oh, you have no other option, what are you going to do about it? So they've wanted to have what they call redundancy. Hey, Phil and Fallon, nice to see you from Steinbach. Yeah, Boeing, I know it's tough. There's a few forums where you have to sort through all of the SpaceX fanboys just bashing Boeing, and all of the people comparing Boeing space to the Boeing airplanes and the hatch blowing out in the airplane and stuff like that. Totally separate companies, but still, it's just really hard to give them the benefit of the doubt right now. I really hope, though, that they're able to solve this, because you really don't want to be limited to a single option for space programs when it's not, the National Space Agency that is that option. When it's a private company, they're at the mercy of stockholders and their own priorities and things like that. And NASA, it's a different era. It'll take us all some time to figure all this out. But I'm hoping that Starliner will come home no earlier than July 4th. That's what we know for sure. So. And let's see. This was another really cool thing that happened. China launched its Chang'e 6 spacecraft to the moon. The back part there is an orbiter, and the front part here is the lander, and the lander landed, and the lander had a little rover on it that drove around and did some cool things. And at the same time, it collected some samples, put it in this top part of the top part, which then blasted off the moon, the first time anything's launched from the far side of the moon. And then it went to the main thing and came back to the Earth. And those samples from the far side of the moon returned to the Earth just the other day. I happened to be fighting some insomnia, and I got the alert at about 1:30 our time locally, and I tuned in just in time to see the parachutes come out, and this little capsule parachuted to the Earth with the first samples from the far side of the moon, landing in the Mongolian desert as planned. And they retrieved it and whisked it away to a lab. And I just saw that they opened it up today. And so the reentry vehicle is that thing on the left. It looks a lot like a very small version of a Soyuz capsule. And then the cylinder that the people in the middle are holding, that contains the moon rocks. They think there's a couple of kilograms in there. And that'll be really interesting to see, because the far side of the moon looks totally different than the near side. There's none of the dark areas, the Maria, the seas. It's all craters and mountains. So the other side of the moon is very, very different. And so samples from there will probably give us a good sense, perhaps, of how the moon evolved like that. And of course, the moon evolved very close to where we live here on the Earth. And so really, everything we learn about the moon's formation is probably telling us something about our own formation as well, if we can just sort of puzzle it out from the limited samples that we've got. Okay, let me see here. Oh, how is time flying so fast? We've had some great questions today. I really appreciate that. Thank you all for asking questions and bringing up things. It's always good to be able to make sure that we cover the stuff that you want to know about. We'd love to hear more about your interests and your observing stories. If you have images, if you have stories, things like that, we'd love to have that. We are hoping to bring our once regular contributor Ulrika back to do some binocular stuff. I've been trying to work out the technical stuff on my end. Ulrika has been ready to go, but it's totally on me that we weren't able to get her ready for this show, but hopefully we'll see her again. And it's always great to see that, because that's, from someone in the field using binoculars on the sky. If you want to take a look at the sky, we do have an event coming up, Canada Day at Assiniboine Park. The Royal Astronomical Society of Canada's Winnipeg Centre is going to be there with solar telescopes. And we didn't talk at all about the sun today, but the sun is doing all sorts of really interesting things. Big sunspots and solar flares and prominences and all sorts of stuff. And it's really fascinating to watch. So if you don't have your own solar telescope, which a lot of people don't, come on down and you will see the latest in solar gear. We've had a few members that have really gotten into solar observing deep. And so there's some of those robotic telescopes, and there's some of those really fancy telescopes that I can't possibly afford, but look really nice. And you can come down and check them out and, talk to me, talk to the astronomy folks and learn a little bit. So join us on Canada Day at Assiniboine Park. We're actually not going to be where the eclipse events were. I think we're going to be over near the Lyric stage. That's where all of their activities are. The details for that are on the west end of the RASC Winnipeg Center's Facebook page, which I will put a link to. But if you search for RASC Winnipeg on Facebook, you'll find it there. Or you can visit our website, which is right there. Thanks, everybody, for joining us. And we will be back either the last Thursday in July or when T Corona Borealis explodes, and we want to go live to that. Thank you all. It's really great to see you all. I'm hoping that we can get some observing done this summer. It's hard right now because it gets to be dark so late. But, when we get to August, sunset starts to start at a reasonable time. Saturn will be getting up at a reasonable time. So I'm aiming for an August event, maybe something for the Perseid meteor shower as a sort of a good time. Thanks for coming. As always, you can hit us up on the various social media pages or space at manitobamuseum.ca. That's the best way to reach me because that comes right to my desk. And the other ones have to get sorted through by our social media director and so on. So have a great evening. I hope you have a good summer until I see you again, and keep looking up.